Hello everyone. Thank you for being here today. So we are going to start with a quick review of what is going on at the IETF. I guess you are all aware these days SRv6 has been evolving very rapidly in its standardization, let's say, journey. So I wanted to highlight first that we have seen enormous advancements when it comes to the compression scheme in SRv6 with draft spring SRh compression, as you can see up there. And the other important aspect that we have seen evolving at the IETF is some clarifications when it comes to the use of arguments in the context of services and SRv6. So if you can take a look there, it will be great. Now, in terms of interoperability, as you know, every year we get together, all the vendors and some operators too. We get together in Berlin at the NTC and we test a lot of things related to SRv6. Particularly during 2024 and 2025, we got to test a lot of technologies related to microseed or next seed compression scheme at the NTC. And as you can see, we've been testing in 2024 mainly, and in 2025, we've tested a lot of applications, as you can see up there. We've tested services like classic IPv4 and IPv6 VPN. We've tested all sorts of services using EVPN, like layer 3 EVPN services, layer 2 EVPN services, and more importantly, and more, it's more attractive. We also tested a lot of services with multi-homing, either for BPWS or VPLS services, and in that particular case, using arguments in SRv6, right? Which is the first use case that we have seen out there of implementations using arguments for to control or to stop boom traffic in a multi-point service, particularly with EVPN using multi-homed Ethernet segments. Okay, and so lots of information there. One additional point too, very important, is the OEM. So as you can see, we've tested. It seems very simple, right? But using ping and using traceroute, those tools that we love, of course, and testing ping and traceroute over a list of seats is always very attractive, at least for me. And then when it comes to deployments around the world, we've seen many lately and in multiple regions. So we've seen cases of mobile backhaul operators or service in the service edge, in the aggregation areas. We have seen customers with or operators with large networks, multiple IGP domains, multiple autonomous systems, going into this journey of moving away from MPLS, whether that is classic MPLS with LDP, RSVP, or segment routing MPLS even, to SRv6, right? And using all these tools that SRv6 provide, particularly for these operators with large networks, like summarization, as Juan was mentioning earlier. One of the biggest points or biggest advantages that SRv6 provides for this kind of networks. We have also seen, of course, new, completely greenfield networks where going to SRv6 and going to IPv6 is just an easy decision, right? And also, as my colleague Fabio will talk to you about, in IXPs, right? This is a case that we wanted to demo here. So that's it for me. I'll give the mic to Fabio here. Thank you very much.
Okay. Thank you, Diego. So I'm here to talk a little bit about our implementation, our deployment of SRv6. But first, I'll talk a little bit about us. You might know that Brazil is a huge country with a big population, right? So in 2004, we started a project called PTT.br to implement internet exchanges in different regions of Brazil. In 2015, the name of the project was changed to IX.br, the Brazilian Internet Exchange. And the main goal of the project is to implement internet exchange in metropolitan areas in Brazil in an 8-kilometer range to exchange traffic in that specific area. Okay. Nowadays, we run 38 IXPs. You can see them pointed in the map, right? Spread in Brazil. And we have more than 4,000 unique ASNs connect to our IXPs with more than 7,000 connections, since an ASN can have presence in more than one IXP or more connections in the same IXP, right? And the historical peak of traffic of all these IXPs was 37.5 terabits per second, okay? So the largest IXP that we run, and actually the largest IXP in the world in number of participants and traffic peak, is São Paulo, right? We have more than 2,700 participants, connect with more than 3,000 routers, and we already reached 25.6 terabits of historical peak in this location, okay? What really makes São Paulo special is that we have a lot of data centers in the area, a lot of interconnection between these data centers, and a very rich economy in Brazil, right? And then it's make the perfect scenario for to create a content hub in Latin America, right? So we have presence in 31 data centers in the area, plus 2 core sites, running with 108 network devices. And in the connections for the participants, we have 99 1 gig ports, more than 1,000 10 gig ports, almost 1,000 100 gig ports, and 27 400 gig ports, just for participants. We are running 300 400 gig ZR transceivers in the network nowadays for uplinks, and more 16 terabits using 100 gig interfaces or transponders, right? So basically, an internet exchange is the main service of an internet exchange is to provide a layer 2 connection between autonomous systems, right? And in our case, we are using a cloud-like topology in a metropolitan area, okay? Connecting all these data centers using multi-vendor devices, right? And as you can imagine, we have huge links with different paths. Usually these links have a lot of transceivers, a lot of interfaces, so in some cases with 13 400 gig interface in the same leg. So we always had the problem to really do proper balance in these uplinks, right? In the legs, and also to balance in ECMP paths. So we always relied on flow-aware transfer, the FAT, in VPLS, to do this properly balanced, right? But not all vendors support that, or sometimes we have to keep asking them, please do that. We want your device, but you don't have this specific feature. Do that, please. And it's very hard to us to keep growing the network or have options of device to grow the network, right? As IXP, usually we have huge layer 2 networks. So we saw the need to move to EVPN. We use VPLS, and we need to move to EVPN. But why? Actually, you can imagine that if we have a common layer 2 domain with a lot of routers from different customers in the same domain, we do have a lot of ARP. We do have a lot of IPv6 neighbor discovery. And that's very bad for all the customers, right? So we saw that using the RFC 9161 to implement proxy ARP and proxy ND in the PE routers, we could really reduce this amount of ARP and ND in the network. So it was very important to move that way, right? And also, EVPN scales way better than VPLS, enhance the network visibility, and it's very easy to move from VPLS using seamless VPLS integration, right? So, and for sure, it's we have RFCs for interoperability between vendors, right? So, okay, but why SRv6? We could use MPLS. It's there. Everyone uses that. Well, as you know, SRv6 is very simple, and we can reduce the number of protocols in the network, and okay, that's good. Also, we could have microloop avoidance, fast network convergence, source routing, all that stuff that we already know, right? And it's very good, for sure. But in our case, we always had the problem with the FAT. So how to solve that problem? We saw that we could rely on the flow label field of the IPv6 header to do this proper balance on our links, right? So we didn't have to wait for vendors anymore. If we use SRv6, it comes with it. It's very good, right? And also, if we decided to move to SRv6, we didn't have to upgrade all our P routers to a different technology. We just had to enable IPv6 in these routers and do the normal IPv6 forward that the device already had for some time, right? So it was very simple. And so, as you can see in these graphs, as we migrated to SRv6, no problem with the balance or the load balance in link aggregations or SMP. We could easily move from VPLS that we already use FAT to a new technology. We use an EVPN, reducing the ARP and in the network, and still do the proper balance, doing a more simple network in our side, right? So it was very easy to deploy. It's very smooth, and we could keep the same network, the both protocols running at the same time, using the VPLS seamless integration with the VPN, and running MPLS and SRv6 at the same time. So the challenge that we have, as all the challenges from an early adopter, right? So lack of best practices. We had to train all our internal teams to a new technology. It's sometimes very hard to find documentations from even for our vendors. We have direct contact with them, but sometimes could be difficult to get that documentation. When we need a new professional in our team, it's very hard to find someone that already knows that, but we have to keep training them. So, and even in the support side, on the vendor side, sometimes we feel that they are not prepared yet to support this new technology, right? But it will come with the time, right? So our next steps, we plan to bring that technology to more IXPs, right? Nowadays we have 5 of them already running EVPN with SRv6. We will try to use FlexAlgo to provide different services in the network. And also we want to use IP performance measures to get more data of the network, more metrics of the network, right? So that's it.